In this video, we will discuss about current electricity. So, understanding of current electricity, first I am taking a small law that is very important for physics. That is what? Ohm's law. In the Ohm's law, what we will study, in which we will study, first we will discuss about the states of the Ohm's law, then we will discuss about different types of the physical quantities. This law is very useful for solving of circuit. Getting? So, what is that law? Ohm's law. What about the Ohm's law? I am explaining. Ohm is a name of a scientist. Ohm is a name of a scientist given a law. What that one? 8 constant temperature. First, this is a condition. Temperature should be constant. 8 constant temperature. The potential difference across the element. Element is what? Resistor, or it is a conductor. So, the potential difference across the resistor is directly proportional to current flow into resistor. Observe. This one is what? This is a circuit. And what about the circuit? Circuit is having elements. Now, what is the elements? Elements are, observe, elements are two types. One is the active elements and another one is passive elements. What I am saying? This is what? This is a circuit. And in this chapter, we will draw many circuits. So, first we should know the circuit. Circuit is what? Circuit is a closed path. What is the circuit? Circuit is a closed path having elements. And what about the elements? Elements are two types, active elements and passive elements. Active elements are what? Active elements are capable of delivering of energy. They are deliver energy. What sort of the elements deliver energy? Battery, cell. They are capable of delivering of the energy. In this circuit, this is what? This is a symbol of cell. Cell having two terminals. One is the positive terminal and another one is what? Negative terminal. So, cell is what? Active elements, and it is having energy and it is delivering of energy. So, elements are, why we are discussing this one? Observe. Circuit is what? A closed path and having elements. And elements are two types, either active or passive. Active elements are capable of delivering of energy, but passive elements are not capable of delivering of energy. They accept the energy. Are you getting what I am saying? They are capable of delivering of energy, but they accept the energy. In the circuit, this cell is what? Active elements. It is having energy and power to transfer them. Power to transfer energy to where? Different elements. Clear? So, active elements are what? Voltage source and current source. Observe, in this circuit, in any circuit we are having some elements, and they are either active and passive. Active elements are capable of delivering of energy. Now this cell is having energy and it is delivering what? Energy to other elements. Clear? So it is what? Active one. Now I is what? Current. Current is denoted by I. I is what? Current. And why this one is the active? Because it is what? Source. And it is, what is the current? We'll discuss deeply about the current. First, only basic I am showing there. V and I both are active elements. Voltage having energy, and current is what? Flow of electrons. It is what? Flow of electrons. It is passing energy from one point to another. What is the current? Cell is having energy and we are taking this energy as electrons, and that electrons passing in this wire and moving. So flow of electrons, what? They are active one. Are you getting? They are active one. So we can say current is active element. Observe, elements are two types. One is the active, another one is a passive. Active elements are capable of delivering of energy, voltage source and current source. Voltage source is what? Cell or battery. And current source is what? Flow of electrons. Flow of electrons. So both one are active in the circuit. So they are in the active elements. And passive one, we are having some elements, resistor, inductor and capacitor. Observe, this R is what? Resistor. What will be the its symbol? Resistor symbol is what? This is the resistor. Clear? Now what about this? This is the inductor coil. What is this? This is the inductor coil. And what about this? This is the capacitor. It is having two parallel plates. One is positive one, another one is negative one. They are what? They are what? Passive elements. And where we use these elements? In a circuit. They are having different use. So in this circuit, I am having this one, and this is what? Passive elements. And what is the use? We'll discuss later when we discuss about the resistor. So what we are discussing, we are having Ohm's law. At constant temperature, potential difference across the resistor, potential difference across the element. And what elements we are using? Resistor, passive elements, is directly proportional to current flow into the element. This is a circuit. And what about the circuit? Circuit is what? Circuit is a closed path. This one is a closed path and having elements. And what sort of the elements? Elements are two types, active elements and passive elements. Active elements are voltage source and current source. Getting? Voltage having energy element, and this is what? Flow of electron, current. So both one are active. Passive are what? Resistor, inductor, coil and capacitor, two parallel plates of charges are what? Capacitor. These are some also there, but mainly in this standard these are sufficient. Resistor, inductor, capacitor. Resistor, inductor and capacitor. Observe. In the circuit, how current flows? Circuit is a closed path. So current, observe, current starts from positive terminal. This is the positive. So current starts from positive terminal of, observe carefully, current starts from positive terminal. This one is what? Again I am drawing. This is the positive and this one is what? Negative. Two terminals we are having. Cell having two terminals. One is the positive, another one is negative. So in the circuit, current starts from positive terminal. Current always starts from positive terminal of battery to where? Negative terminal of battery. The path of the current is what? This is the cell. It is having positive and negative two terminals, and current will be flow from positive terminal. So from this terminal, current starts to flow and flowing like this. This is the way of flow of current. Clear? Start from positive terminals to negative terminal. One is important concept for the circuit. Now, whenever, this is also very important, whenever current, listen carefully, whenever current enters to any element, whenever current enters to any element, that entering point, this is the entering point, this current is coming from this terminal to this terminal. Now that point current is going into where? Resistor. Current is entering in this resistor. So this entering terminal of a resistor will be what? Positive. Entering terminal of resistor will be what? Positive. And leaving terminal, current is, this current is flowing, this I current, this I is flowing in this resistor. Passive elements, in this current is flowing, entering point is what? Positive, and this is the conducting elements, and conductor having property, current can easily flow. We know where conductor is what? In the conductor current can flow. Iron, copper, aluminum, they all what? Conducting. So resistor is a conductor. This element is what? Conductor. So in which current can flow easily. So current starts from positive terminal of battery or cell, and when enter to any element, place of this we can use inductor, capacitor. Then entering point is what? Positive terminal, and leaving point of current. This current is entering to this point, this one is point, will be what? Positive, and leaving will be what? Negative. Are you observing? Leaving. Entering point is positive and leaving point will be what? Negative. So both 2 points are very important. Listen carefully. I am just describing circuit. We are discussing Ohm's law, and Ohm's law having this circuit. So first we should know about the circuit. Circuit is a closed path having some elements. Elements are two types. Active elements, they are capable of delivering of energy, like voltage source and current source. Passive elements are accepting of the energy. Some are storing the energy and delivering. Resistor, inductor and capacitor. Getting? Now, these are what? Symbols of these elements. In this circuit, we are having one active source and one what? Passive element. Second thing, we should know circuit is what? Closed path. Circuit should be closed. Circuit never be open. Current starts from positive terminal of battery to negative terminal. Current starts from positive terminal of battery to negative terminal. Second point, whenever current enters to the any element, that entering point is called positive and leaving point is called what? Negative. These ideas, these concepts are important for the next Kirchhoff's law. We are discussing 12th standard, and in the 12th standard, this you already studied in the 10th standard, but in this standard we will discuss in advance. Why? Because by this concept we will solve some more concept like Kirchhoff's law, KCL and KVL. In the KVL, Kirchhoff's voltage law, there is a closed path, and that require what? Ohm's law. Clear? So that one is very important concept. Now observe statement of a Ohm's law. This is the physical condition at constant temperature. The potential difference. Voltage is also called potential or potential difference. No problem. Both are, all are potential difference, voltage having unit volt. V-O-L-T, volts, and it is denoted by V symbol. Clear? So, potential difference across the resistor. Resistor is a conductor element. So, this is the resistor and dropage across this one is V. Why V? Observe. Why dropage is V? This element, this is the resistor, and dropage, potential difference, voltage across the resistor. What is the voltage across the resistor? This resistor having two terminals, this one and this one, and across this one only one voltage source. Yes or no? This element having only this source. It means what? This having only this source. So how we will solve this one? This having, what is the statement? Potential difference across the resistor. This element having only this source. So dopage across this element is V, this one. So this is the potential difference. Across this one is what? We are having only one source. So we will use this V directly there. So potential difference across this element V is directly proportional. Directly proportional means once when one quantity increase, other will be increased. If one quantity decrease, then its proportional quantity will be decreased. Like this. Increase means increase. Another one decreasing means another quantity will be decreased. Like this. This is the meaning of the proportional. So this is the symbol of proportional. So potential difference across the element V is directly proportional to current flow into the element. And what current is flowing? What current is flowing in this element? In this resistor, I current is flowing. So what we can say? Potential difference across the resistor, whatever dropage across this one will be directly proportional to current flow into the elements. So dropage across the element will be directly proportional to current flow. What current is flowing in that element we will write. So in which I current is flowing, dropage is V, so both will be directly proportional. Once we remove this proportionality, we are getting a constant, and that one is what? R. Clear? So V equal to Ri, we solve for the R equal to V upon I. So we can say where V is the voltage or potential difference or potential, I is the current, and R is what? Proportionality constant, or we can say resistance of the conductor. Resistance of the conductor. Clear? Now this R is what? Resistance. We will study details about the resistance or resistor in the next upcoming classes. So you will observe that one there. Now I am just giving the idea of the Ohm's law. So in this class we are discussing only statement, details of the Ohm's law. So Ohm's law is what? Dropage across the element will be directly proportional to current flow into the element. Dropage is V. In this circuit we are having only this element, passive element. We want to dropage across this one is what? V, and current is what? I, and this dropage will be directly proportional to this current. That is the Ohm's law. V is directly proportional to I. like this. So we can say resistor is the ratio of voltage to current, and it is the constant thing. Resistor is what? Voltage to current, and it is what? Constant. Clear? Now once we draw graph between V and I, voltage to current, observe carefully. We are having two active elements, voltage and current. We want to draw the graph between both. So voltage to current, we are getting a straight line graph like this, and this is showing, this straight path showing what? Slope, and that slope is what? 1 upon resistance. Clear? This slope is what? 1 upon resistance. What is this? This is the slope. Clear? Are you getting or not? Yes. So this having slope, and this one is equal to 1 upon resistance. We can say slope equal to what? This slope equal to 1 upon R. Clear? Slope of this graph will be what? 1 upon R resistance value. Observe carefully. We are studying Ohm's law. How we are getting this graph? In which we are having V is directly proportional I. Once we increase voltage, we are increasing voltage, current is also increased. Observe this one. V is directly proportional to I. When we increase voltage, current is directly proportional, so current will be increased. Voltage increase, current increase means we will getting what? Straight path, like this, straight line. So this is the graph between voltage and current of, current is what? A straight line. Now this is the basic Ohm's law. In another way we can also define Ohm's law. And what is this one? Observe, at constant temperature current density is directly proportional to electric field intensity. Again two another physical quantities. Now observe, in which voltage, current and resistance, these all are what? Physical quantity. In the 11th standard you studied some quantities. Physical quantities are what? Those quantities which are measurable, and there are two types: fundamental quantities or base quantities. Second one is what? Derived. 7 we are having fundamental quantities, and remaining derived is what? They are derived from 2 or more base quantities. And voltage, current and resistance are what? Physical quantities. Clear? So you know these things well. Now two more physical quantities we are having: current density and electric field intensity. In between we are having one ratio. At a constant temperature current density is directly proportional to electric field intensity. J is directly proportional to E. We want to show how this one is the Ohm's law. If we are having R equal to V upon I, then we can say that one is the Ohm's law. Yes or no? Voltage to current ratio is what? Showing Ohm's law. But we want to show current density is directly proportional to electric field. How this one is the Ohm's law? So I am taking current density is directly proportional to E. H per definition, current density is what? Current passing. Once we solve this proportionality, we are getting a coefficient, constant, proportionality constant, and that one is what? Sigma. Or sigma is what? Conductivity. Observe, these all terms are important. In details we will discuss each and every term. Don't bother. In details we will discuss voltage, current, resistor, current density, electric field intensity, conductivity, resistivity. Don't bother about these things. We will give details each and everything. Now first is what? Now we are studying only Ohm's law, basic Ohm's law is this one, and we are having one relation also, and we are saying what? This one is also Ohm's law. How is it? So I am showing this one. Current density is what? J equal to, once we remove, we are getting a constant, and that is the sigma, and it is called what? Sigma. How we will pronunciate sigma? This is the sigma, and it is called what? Conductivity. What is the proportionality constant? Conductivity. So three things we are having: current density, conductivity, and electric field intensity. Now in detail we will discuss later, but just I am describing definition of these physical quantities. Current density is what? Current passing per unit area. What is the current density? Current density is current passing. What is the current density? Current density is current passing per unit area. And conductivity is what? Reciprocal of resistivity. What? New words you are listening. All are very important. Current density is the current passing per unit area. Conductivity is what? Reciprocal of resistivity. Resistivity, rho. It is sigma, and this one is what? Rho. This is what? Rho. Rho is what? Resistivity. And electric field intensity E. And what is this one? Voltage to current, voltage to length ratio. What is the electric field intensity? It is the voltage to length ratio. Now solve this equation for V upon I. Again I am revising. J is directly proportional to E is also a Ohm's law. How this one is the Ohm's law? I am showing there. Once we remove this one, we are getting a constant, proportionality constant sigma, and this is called conductivity. As per definition, J is current passing per unit area. Sigma is reciprocal of resistivity. Electric field intensity is what? Voltage to length ratio. Clear? Now V upon this equation we are solving for V upon I. What we are getting? I will be there. Cross multiplication we are doing. I will be going there, and rho L will be there. So V upon I will be rho L upon A, and that is what? V upon I is what? R. V upon I is the R. So we can say this equation showing V upon I equal to this one, and this one is equal to R. This one is what? Rho L upon A is what? R. How this one is the R? Observe. This is also having one concept. How this one is R? Once we are having a conductor. Observe, this is a one conductor. Like this. There we are using resistor. Now I am using one wire there. This is a one conductor, and length of this conductor is small l, and its area of cross section is A. Observe, this is a wire conducting element. Its length is L, and its area of cross section is what? A. Then this wire's resistance is directly proportional to length of this wire's resistance is directly proportional to this length, and listen carefully, this wire having what? This wire is having length L, area of cross section A. So resistance is directly proportional to length of the wire and inversely proportional to area of cross section. Once we combine both equation, what we are getting? Resistance is directly proportional to L upon A. Observe, I am showing why rho L upon A is the resistor. Are you getting what I am doing? I want to show rho L upon A equal to R. Why? So for this I am taking a one wire. Length of this one is L, area of cross section is A. So this wire resistance will be directly proportional to length, directly proportional to 1 upon area, or we can say inversely proportional to cross section area. When we combine both, then we are getting this one. When we solve this equation, then what we are getting? R equal to rho L upon A. Yes or no? When we remove this proportionality, we will get one coefficient, one constant, and that is what? Rho, resistivity. So rho L upon A is what? R. So we can say V upon I equal to rho L upon A equal to R. So finally we can say current density is directly proportional to electric field intensity is also a what? Is also a Ohm's law. So in this way we obtained results or detailed statement of Ohm's law. So Ohm is a scientist and given a law, and that one is what? Voltage is directly proportional to current. And another way we can say current density is directly proportional to electric field intensity. That's all about this class. Thank you so much.